Hello, today we're going to talk about factoring quadratics using the greatest common factor method. We've already listened to the video, Teach Me How to Factor by Westerville South High School. If you have any questions, you should refer to that music video and this video, or you can ask Miss Miller or myself, or again, ask your classmates. Greatest common factor, or the GCF. We will use GCF to abbreviate it and keep it simple in class. What we're doing is we are going to be finding the greatest or the largest factor. And again, a factor is any number or term that goes into everything that all of our terms have in common. We're going to then pull that term out of each of our terms. In our first example, we have 7x plus 21. We have 7x and 21, and both are divisible by 7. Divisible means it can be divided evenly out. We remember that when we talked about our prime factorization. Since we can divide both 7x and 21 by 7, we're going to do that. We're not actually dividing, remember, because there's no equal sign, but it's very similar to dividing. So I've set it up with the factoring out the 7. I've written 7x over 7 and 21 over 7. But because, again, there's no equal sign, I have to leave the 7 in my final answer. So I have 7 times the quantity x plus 3. If I wanted to then distribute this back, I could take 7 times x, and I would get 7x, and take the 7 times the 3, and I would get 21. We don't want to distribute that back out, but if we did, we would end up with our original problem. A quadratic. This is what we are going to be working on. We have 3x squared plus 6x plus 9. What do 3x squared, 6x, and 9 have in common? Well, the 9 doesn't have an x, so it can't be an x. So we now need to focus on the numbers, since our variable is out of the question. 3, 6, and 9 are all factors of 3. So that's what I'm going to focus on factoring out. I'm going to factor out a 3. So once I've factored a 3 out of everything, I'm left with x squared plus 2x plus 3. Because again, this is very similar to dividing. I'm not actually dividing because nothing goes away. There's no equal sign. So I don't have an equation to a balance. But I'm keeping my 3 here and just pulling it out, pulling it away from each of my terms. My third example. I have x to the 4th minus 2x cubed minus 5x squared. In this one, my constants, my numbers, sorry, not constants, coefficients, my numbers are 1, -2, and -5. Those numbers have nothing in common. So now I do need to look at the variables. I have x to the 4th, x cubed, and x squared. What's the largest number of x's that I can pull out? If you said x squared, you would be right, because it can't take any more than what the smallest number is. And the smallest is x squared. So I'm going to pull out an x squared from everything. Which means I'm pulling that out here. Once I've done that, I'm subtracting the exponents. Remember the rules of our exponents. 4 minus 2 gives me x squared. My numbers stay the same. 3 minus 2 gives me x to the 1st. I don't need to write the 1. My numbers again stay the same. 2 minus 2 is 0. And anything to the 0 power is 1. So this becomes x squared minus 2x minus 5. And I leave my x squared that I factored out on the outside of my problem. My final example, I have x squared y squared plus 5xy plus 6y squared. Again, I'm going to be looking at the variables because there's no numbers here that are the same or that I can factor anything out of, because I would have 1, 5, and 6. This doesn't have an x, so I can't factor out any x's. I have y squared, y, and y squared. So what's the largest thing I can take out? If you said y, you would be correct. So I'm pulling out a y from everything. So now I have y times x squared, y plus 5x plus 6y. I can't combine any like terms because now nothing is the same, nothing was the same before. It doesn't change anything. I rewrite it with the factored form. Please try your challenge problems that are on your guided notes page. Again, if you have any questions, please do not hesitate to ask. Thank you.